Recording in progress.
The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: Agricultural, Earth and Environmental Sciences, Engineering, Chemistry and Physics, Life Sciences and Mathematics, Statistics and Computer Science. Engineering is offered on the Howard College campus, Agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are Agricultural Engineering, which is offered in Pietermaritzburg, and Geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Upalinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Center showcases the college's scientific achievements and promotes the public understanding of science, engineering and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. College has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centers within the college. The African Center for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Center for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Center for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centers at the university, the Center for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Center for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser, and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university, equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development and upliftment of the wider community. The college also engages in activities involving the pursuit and understanding of science, engineering and technology through exhibitions, festivals and roadshows that target high school learners and the general public. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
With the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in Canada that teach agriculture and natural sciences.
What I think is good about this college is the level of international collaboration that we have. We have friendships with universities all over the world, which means that we're keeping up to a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do science studies here. Life begins here.
We continually strive to be academically excellent, innovative in research and critically engaged with society. We invite you to join us or work with us to be part of this exciting team.
Okay. Good morning, everyone. Is my mic working fine, Daniel? Can you hear me? Can you guys hear me?
Yes, Ashwin, we can hear you.
Okay, that's perfect. Thanks. Okay, so I'm in a bit of I've got some trouble on my end, right? So I've got some electricity is down, so I'm running off my laptop. So if I bomb out during the session, just wait for me. Don't leave. I'll be back in probably in a few seconds, right? So what we're going to do today, we have a few people here today, but that's fine. You guys can ask questions as we go. But we're going to go over a past paper. So this paper is a Department of Basic Education paper. It was right, so it's a 2021 paper, so it's last year's one. Yeah, so it was given for the half-year exams, and hopefully this will give you some practice for whatever exams you're writing next week. So how I'm going to do this is I'm going to switch between the question paper, the answers, my whiteboard, and your chat, okay? So I want you to communicate in the chat. We're going to do multiple choice first. Just a few tips about an exam paper, right? So An exam is about two things. An exam is about knowing the content in the exam, being very good at it. Obviously, throughout these years, you would have studied, your teachers would have taught you, you would have done a lot of tutorials, but a lot has to do with that exam. So all of that hard work culminates into you sitting down for that period of time and answering the paper. So when you get to the paper, it's very important that you have a plan. Okay, how you're going to approach the paper. You got to manage your time. You have to manage your time properly. And this requires you from the beginning, whenever you come to any new paper, to look at the paper, right? Most important thing with the exam paper, at the beginning of the exam paper, take 5 minutes. Now, I'm sure your teachers would have told you this, but you take 5 minutes to read the paper. So you go throughout the paper, you read any rules. It tells you how many pages are in the paper. There's 15 pages, 4 data sheets. You make sure you have them.
I think it's on the...
Hello? Okay. Does somebody want to ask something? Okay, no. So, for example, I know this might seem like a simple thing I'm telling you, but 15 pages, you check if you got 15 pages. Because if you got 14 pages, it's a problem. You don't answer one page, you don't have the marks, right? So, simple things that I check that you have all the papers, check it's the right paper, and then go through the instructions carefully. Read the instructions, absorb the instructions. Get hold of past papers now, read the instructions. Don't just assume your paper is going to have those instructions. Read it, see what's different. And then go through the questions. Look at it. Look at the paper. This is question 1. These are question 2s. You'll recognize questions. It'll build your confidence up because you know that there's certain things you can do. You might come across questions you don't know how to do. But that's the good thing. That's how the mind works, right? So we have something called a back burner. Whenever you present a problem to your brain doesn't forget it, okay? It puts it on the back burner. So while you're answering your questions, the ones you can do, your mind is processing the thing you're struggling with. And when you get to it, you'll have some sort of idea, because subconsciously you've been thinking about it. You can solve the problem. So go through the paper, look at it, make sure things look familiar to you, and then make sure you have all your data sheets. If they say 4 data sheets, if you don't have a periodic table, it's a big problem. You can't get molar mass, you can't get electronegativity, put your hand up and say, please, periodic table is missing, right? Look for your electrode potentials, stuff like that, and then you're good to go. So read your paper, check your paper, take about 3 to 5 minutes, 2 minutes doing that, and then you start your paper. Okay, you pace yourself like that. So let's start with this question, 2021, the half-yearly exam. So the first question is, which one of the following compounds has hydrogen bonds between the molecules? So what I want you to do is, I can see that there's 7 people in the chat, so there's 5 students here. In your chat, just put on what you think 1.1 is very quickly. Okay, we have someone says it's A. Anyone else? It's an A here. Okay. Two people say A, right? So 3 people haven't given responses. That's fine. Let's work on this problem now. So what would be the first thing we need to do in a problem like this? So when we're dealing with a problem like this, we have to, the first thing we have to do, and I know it's only 2 marks, right? Um, I'm just checking for the whiteboard. Microsoft Whiteboard, okay. Right, so you guys can see the whiteboard? Is that fine? So the first thing we have to do with this question, this is a question okay, I'm just going to stop sharing this one moment, right? And I'm going to close this. All right, so you probably can see that, right? Okay, so this is the June 2021. And we're dealing with June 2021. And we're dealing with question 1.1, multiple choice. So the first thing we have to do is we have to draw these compounds out. And so the first compound is pentanal. Do you guys know what pentanal is? Very quickly, if you can unmute, what type of compound? So the pentanal, so let's just write out what we have, right? Pentanal. So as I said, I know it's a multiple choice question. I know it's a quick thing. You just ring it and you move. But there's a few gems in this question, okay? Pentane 2-on that will be used in other questions. So it's good to just spend some time here. This is pentanoic acid. And the last one is methyl butanoate. Okay, so what do we have to pay attention to? Now we've got 4 carbon compounds here. They're all a little bit different. We have, they're asking us which one of these compounds has hydrogen bonds. So in order to know what has a hydrogen bond, we need to know what a hydrogen bond is. Does anybody have an idea what a hydrogen bond is? How does a hydrogen bond form? Anyone? Okay, so a hydrogen bond is a bond that forms, right, between a hydrogen and some electronegative atom, but it's a polarized hydrogen, right? So what we're looking for in a hydrogen bond, I'm just going to quickly write it here. So what we're looking for in a hydrogen bond. So there's been a lot of discussion about hydrogen bonds. People done a lot of research. It's not purely electrostatic. There's some spatial and orientation that's involved in it, right? So there's some orbital stuff, but that's complex. That's how we will explain this is you have what you're looking for is you have some electronegative atom like oxygen or hydrogen, and then you have a hydrogen attached to it. So this would be within your molecule. You're looking for something like this. You're looking for an oxygen or a nitrogen or some other electronegative atom, right? And what this electronegative atom does, it pulls some electron density away from the hydrogen. And so that creates partially negative, and that creates kind of a partially positive, right? It's not totally, but it has some nature. Then what hydrogen bonding would be, so I'm just going to call this R. Okay, I'm just going to say that that's the rest of the molecule. And then you have some other molecule or some other atom that would let's say it's a carbonyl, for example, and I don't know, we can just call that R. And this would be a kind of partially negative, and you get some H bond, right, between some other electronegative atoms. So what are the features we're looking for in the molecule? They're asking us which one of these molecules has the potential to do hydrogen bonding. So we're looking for something like this. We're looking for a hydrogen atom that's bonded to some electronegative atom. Now, I'm going to give you another chance again. Okay, let me not drag this question too long. Let's do the question. So we have to draw these out. You got your pen and you got your now. That's important here. So pen tells us that it's a 5-carbon chain, right? So 1, 2, 3, 4, 5. And what does Nell tell us? Does anybody know? You can just put it in the chat. If you don't want to unmute and speak, just put it in the chat. I'd like you guys to respond, okay? If you don't want to do it with the mic, that's fine, but you can put it in the chat. What does Nell tell us? What type of molecule is this? What type of compound? What type of organic compound is it? It's an aldehyde, right? So you will have that. Now, you know that pen means 5. You know that the Nell means that there's this aldehyde portion here. Or you can fill in, carbon has the valency 4, so carbon will take 4 bonds. So if that carbon has 1 bond there, it takes 3 other hydrogens. This one takes 2 more hydrogens. This takes 2 hydrogens. This takes 2 hydrogens. So you can see that every carbon has 4 bonds. This carbon here has 1, 2, 3, 4. And you've got your carbonyl here and your hydrogen here. And that's pentanal, right? The next compound we're looking at is your pentane 2-one. Now, pentane 2-one is what type of compound? Very quickly. Okay, there's someone put something in the chat. Let me have a look quickly. Ketone. Okay, that's good. So it's a ketone. So what do we need to look at? We look at the pen. That means 5. We've got a 2 here, which is important. And we've got an own. The own tells us ketone. The 2 are going to tell us the position. And the pentane tells us there's 5. So when we draw it, again, we draw 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if that's 1, 2, 3, 1, 2, 3, 4, and 5, then your carbonyl is on the second one here. There's your carbonyl there, right? And then you have fulling. Remember, carbon takes 4 bonds, right? In your organic compounds, valency of 4, carbon going to take 4 bonds. Wherever there's no other atom, carbon will take the hydrogen. Okay. And so you end up with something like this. Now, there's a reason why I'm drawing it in this expanded form, and I'll show you just now. The next one, pentanoic acid. Now, very quickly in the chat, tell me what pentanoic acid is. What type of molecule? Okay, good. Okay, carboxylic acid. Right, so again, it's 5. 1, 2, 3, 4, 5. Right, bonds. That's a single bond. And then we have a carboxylic acid, so that would be, this would be the carbonyl group, and then you would have your OH group. Right, this is like your, this is the same family acetic acid belongs to. Acetic acid with ethanoic acid. So again, you have your hydrogens here. You have to fill hydrogens in. Right, and so that's your pentanoic acid. And then the last compound, very quickly, is methylbutanoate. Now, methylbutanoate is what type of compound? What's a noate at the end? Okay, we have someone in the chat again. Okay, one person is answering all the questions, right? Thank you. It's Esther. That's good. That's correct. So, how would you draw it? Methylbutanoate. So, 1, 2, 3, 1, 2, 3, 4. Right? You're going to have 4. 1, 2, 3, and 4. And then the fourth one, obviously, you're going to have your carbonyl. And then you're going to have the oxygen, and you're going to have your methyl. And then everyone else takes, every other carbon takes the hydrogens. And so what we have now, what we've done, and okay, it took us a few minutes to do, but we've got 4 groups of compounds. We've understood what they are, what families they belong to. They all have some kind of carbonyl on them, but only one of these compounds can form a hydrogen bond. And I'm going to ask the question again, right? I'm going to ask the question after drawing this again in the chat. Which one of these compounds has the potential to form a hydrogen bond? Okay, so someone says, so would the answer be C, right? Anybody else want to change the answer now? Okay, so the answer is C, right? And the reason why the answer is C is because when you, let's go to compound A, right? You see, there's no hydrogen here in compound A that's attached to an electronegative atom to establish this kind of polarization, to make the hydrogen partially positive enough to interact with something that's partially negative. Okay, so A is ruled out. If you look at B, there's no hydrogen in B that's attached to an electronegative atom that can polarize it. If you look at D, there is no hydrogen atom attached to any electronegative atom. But when you look at C, you come to this portion here, right? If I had to redraw that OH again, just on its own, suddenly now you'll see that that oxygen, right, that hydrogen, there is that kind of relationship that exists there. Okay, and so it can do the hydrogen bonding. Does that make sense? Is everyone happy with that? Anything you guys want to ask in this question? Any questions you have about this? Can we move on? Listen, please feel free to put your mic on at any time and ask a question, right? There's few of you, So we're not going to talk over each other or anything like that. That's to 1.1.1. So let's do 1.2. So the 1.2. So 1.2 says, to which homologous series does a compound with the molecular formula C6H12O2 belong? Okay, C6H12O2. So let's see in the chat what you guys have to say. Okay. Okay, so Shreya again says D. So yes, the answer is D. Okay. Now, how are we getting that answer? So you guys would have learned formulas. Okay, so you would have learned formulas. Does anybody want to explain how we're getting that answer, or should we just leave it at D? Let's leave it at D, right? This is something you would have learned in school. Let's not. You can identify it from the formula. Is anybody confused about 1.2? Do you want me to explain it any further? No, we're fine. Let's move on, right? So, next question is, of course, 1.3, right? So, which functional groups are involved in the formation of esters? So let's see in the chat, multiple choice. This is like Who Wants to Be a Millionaire, right? We're asking the audience. You can dial in your answers. 1.3. Which functional group are involved in the formation of esters? Okay, so we got some answers here. C. We got somebody is asking if it's a D. Okay. So you guys know what esters are, right? So esters are compounds that would have esters will be compounds that would have this kind of setup, right? We have some kind of R group. R just means, R is not an element, right? It just means some generic kind of alkyl group that's present, organic group that's present. Not sure if you've seen those R things. So, and then we have, here's the chat here. Okay, the school. Oh, you mean the section? What do you mean, Chamber? You can unmute and tell me. What hasn't the school covered yet?
Our school hasn't covered like this section in general. We only do this next week.
Okay, is this section, are you talking about organic chemistry?
Yes, sir.
Or are you talking about esters?
Organic chemistry.
Okay, so is this something that's coming out in your test, in your exam?
It is, sir, but we only write on the 20th of June, paper 2.
Okay, Okay, so there's a flexing in the time in the dates, right? But that's fine. We can go over this very quickly, right? Thank you for letting me know that. Okay, so we have this kind of setup. So you have an oxygen, and then you have another alkyl group here, right? And so these compounds form from reactions between. You would have this kind of setup, right? You would have that, and we can. This will just be some extension there, and then you have this. This compound here, right? And you get some activity in that area, right? And this will bring you to here. So what are the functional groups involved here? What were the options that the question gave us? Shreya did say the correct answer. So you need, the answer is C, right? So hydroxyl group and the carboxyl group. Hydroxyl group and the carboxyl group. Is there any questions around that? Is that fine? That's fine, okay. So let's move on to the next question. So the carboxyl would be your carbonyl compound with the OH attached to it, right? And the hydroxyl would be the OH. And that's the formation of esters. That's a famous reaction. That's important. That comes out everywhere. Every exam, the formation of the ester comes out either in multiple choice, in the organic section, or even in your equilibrium section. They use it as examples in those ice tables, things like that. So learn that. That's a famous one. And obviously the other product is water. From that ester formation, the other product is water, okay? But if we come across that in more detail, we'll go over it. So question 1.4, it says the equation below represents a reaction at equilibrium. Represents a reaction at equilibrium. Which one of the following will change the color of the mixture from yellow to orange? So here are options. We can add some sodium hydroxide pellets. We can add some concentrated hydrochloric acid. We can increase the pressure at constant temperature, and we can decrease the pressure at constant temperature. So very quickly in the chat, put your A, B, C, D. Let's see what you guys think about this. Please guys, participate, right? So the chats is not something that we'll view in the recording. I don't think so, to the best of my knowledge. So feel free to tell me what you think the answer is 1.4. Listen, you have to have an opinion for the answer, right? First of all, what is this question testing? What's the concept being tested in the question? It's very easy to look at this question and see chromium and 2-, and then your brain starts thinking redox. Your brain starts thinking balancing redox equations, or it starts to think about E0 values. But what is this question testing? What is the chemical concept it's testing? It's a very important skill to be able to identify, right, what the question's asking. Who can tell me very quickly? Okay, let's just ask for the answer. What's the answer? A, B, C, or D? 1.4. Okay, I'll tell you the answer, right? The answer is B. The answer is B. So tell me why the answer is B. Why will adding more hydrochloric acid Okay? Change the color of the mixture from yellow to orange. Anyone? Whose principle is this about? Whose principle is this about? Have you guys heard of the Chateliers Principle? I'm sure you would have done the Chateliers Principle. Have you guys done the Chateliers Principle? Just put a yes or a no in the chat. Yes, good. No. Okay, so most people are saying yes, so that's a good thing. The Chateliers Principle says that when a chemical reaction is at equilibrium, right, and when you present a stress to that reaction, that's in equilibrium, the reaction will shift in a direction to relieve that stress. So when you have this kind of, the question is telling you that the reaction is at equilibrium. It's telling you that. It's got the equilibrium arrow as well. So when you have this kind of setup, you want the reaction to shift to the right, because if it shifts to the right, it will become orange. If it shifts to the left, it's going to become yellow. So they're asking you, what must we do to shift it to the right to make it more orange? And so you obviously, if you add more acid, if you add hydrochloric acid, which is HCl, right? Remember, hydrochloric acid, HCl, is H plus Cl minus. When you drop that into the solution, you're adding more H plus to the solution. And by adding more H plus to the solution, you're going to shift the reaction to the right, because now the reaction sees this as a stress. It needs to get rid of that H plus. And the only way the reaction knows how to get rid of that H plus is to use it up. Okay, does it make sense? And it pushes it to the right, and it makes the solution orange. So this question that they're asking you, although it has to do with some other concepts, this is about the Chateliers Principle, right? Any questions about this? You can unmute and ask. Anyone? You can just put your mic on and you can just ask if you're not happy with the answer. Are we good? Okay. Let's move to question 1.5, right? So question 1.5 says, question 1.5 says, consider the potential energy graph for the reaction. So has everyone seen the potential energy graph before? Just quickly, yes or no in the chat. Okay, good. Okay, so this potential energy graph is showing you, it's showing you different states, okay? Showing you the course of the reaction. And it's got different points in it, different points. But as the reaction proceeds from its reactants and it goes all the way to its products, there is a change in the potential energy of the system. This change in potential energy comes from intermolecular forces, right? It comes from so as your reactants sit in the vessel, they have, they kind of interact with each other, they feel each other, they repulsed by each other, they're attracted by each other. These kind of interactions create a potential within that reaction vessel. And then after the reaction finishes and you're left with products, those products also interact with each other. They get, repulsed by each other, they get attracted by each other. There's interactions, and so you develop a potential energy there because of purely from the fact of where they are and what they're feeling at the time with respect to what's around each other, right? And so you have a potential energy change in the system. And so the question is asking you, consider the potential energy graph, and it's saying The activation energy for the forward reaction, right, in terms of PQR is, very quickly, you just put your answers in the chat for me. A, B, C, or D? Now these things are representing points and distances. Q would represent here, RP would be there, that portion there, QR would be there, and QP be here. So very quickly in the chat, tell me what you think the answer is. Which distance is representing the potential, the activation energy? The chamber says C. This is question 1.5. Anybody else? Shreya, are you saying D for this question? C. Some people are saying C. Okay, maybe this is worth doing on the whiteboard. Okay, so let's move this up a bit. This is question 1.5, right? So let's just redraw this, the best I can redraw it. So you have this axis, you have that axis, and then you have the energy profile, which is doing something like that and doing that. And then you have points. Now this point is, we say it's Q. We have this point here. This point is R. And we have a point P here. Now this is not drawn perfectly, but this is your reaction coordinate. It's proceeding that way. And this is your potential energy in kilojoules per mole. I'm just going to say potential energy, and that's in kilojoule mole minus 1. Okay, so when we look at this energy profile, they're asking us for the activation energy. So first of all, let me draw a few things in here. The first thing I want to bring your attention to is this is the energy of where your reactants are. Right? And this is the energy of where your products are. Okay? And so if you had to draw a line across there, and if you draw a line across there, the difference between the products and the reactants, the energy, that's the change of the free energy for that reaction. Okay? But that's not what the question is asking. The question is asking is what is the activation energy? So the activation energy is the energy that must be overcome for the reaction to proceed. And when you look at this diagram, right? If we look at this this QR is not the energy that must be overcome, because this is some arb point here to the reactants and the Q. Now, if you are going backwards, if you are going in that direction backwards, yeah, your products, in order to go back to the reactants, would need to overcome that amount of energy, but that can't be your answer. It's asking for the activation energy for the forward reaction. So the activation energy of the forward reaction would be here, your products are here, right? And this is the activation energy they need to overcome. So that, in order to move forward, these products need to overcome that amount of energy. So it's going to be QP, right? And QP here is what? What's QP? Let's have a look. Let me just so let me share the question again. QP is D. So the answer is D. Okay. So whoever said D, well done. But I hope you guys understand how to interpret that diagram now, right? Activation energy would be, for the forward reaction, would be the amount of energy your products need to overcome before the reaction can proceed. If they want the reverse reaction, then you go from your reactants. Common sense, right? You just have to understand what each one of those points are saying. Any questions about that diagram? A diagram is important, comes out all the time. Any questions? Anybody have any questions? You can put your hand up, you can unmute, or you can put it in the chat, right? Nothing. Okay. Let's move on to the next question. So next question is saying, it says a reaction reaches equilibrium in a closed container according to the following balanced equation. So you've got your 3H2 and your N2, and that's going to produce your 2NH3, okay? And so the question is asking you, which one of the following changes will increase the value of the equilibrium constant? Okay, now this is another question that is got a few kind of things you got to watch for. So let's see your answer. Let's put it in the chat. Question 1.6 in the chat. Right? What does everyone say? What do you think the answer is? A, B, C, or D? Very quickly. This is an equilibrium question. Okay, this has to do with equilibrium. I think we went over that stuff yesterday if you were present, but I'm sure you would have done this in school. Very quickly, guys, just put it in the chat for me. A, B, C, or D? Don't be afraid to get the answer wrong. Go with what you would put in the exam. Commit to an answer, okay? Nothing. Okay. First of all, the first thing that may seem tricky. Okay, so we have one answer, okay? There's something I need you to understand very carefully about these questions that have to do with equilibrium. And I want you to follow me. There is a difference between applying some stress to a system and causing the reaction to shift left or right in order to re-establish equilibrium, and actually changing the equilibrium constant. There's a difference. Okay? Let me explain what I mean. If you have a reaction at equilibrium, right? And if you strain the reaction, if you stress the reaction by adding some product or reactant, that kind of stress will cause the reaction to shift in this direction to relieve the stress. If you add in reactant, it'll shift forward to use the reactant. But the equilibrium constant doesn't change. As long as you keep the temperature constant, the equilibrium constant won't change, right? But there is a change you can do that will actually change the equilibrium constant. Okay? And we know this because we studied equilibrium. We know that the equilibrium constant is always quoted to a temperature, always. When you do any equilibrium problem, it could be your ice tables, it might be some question they ask you in the Chateliers Principle, but when they give you the K value, they always quote the K value to a temperature. Okay, that's important, because that K value is only true for that reaction at a specified temperature. If you change the temperature, you change the K value. So that's your hint. Which one of the following changes will increase the value of the equilibrium constant? Making sense? So let everyone try again. Try again. You tell me 1.6. Which one of these answers, A, B, or C, will increase the value of the equilibrium constant? Very quickly. Okay, I have one person that says C. Anybody else? One person has said C. This is question 1.6. They are correct, okay? And the reason they are correct is because if you look at this part here, you see here, that delta H there, I think I've got a highlighter here. So that delta H is saying is less than 0. That means what? It means it's negative, okay? And so a negative delta H means that when this reaction proceeds, it's going to give off energy, right? It's going to give off energy. It's giving off that energy in the form of thermal energy, okay? It's giving off thermal energy as it proceeds. So if you want the equilibrium constant to increase, right? If you want it to increase, remember what the equilibrium constant is equal to. The equilibrium constant is equal to the products over the reactants raised to their powers. Products over reactants raised to the powers. At equilibrium, products and reactants will distribute themselves in such a way as to satisfy the value of the equilibrium constant. But let's just say you want that equilibrium constant number to be higher. It means that you have to have a redistribution between your products and reactants to have more product. And so if you want more product, right? If you want more product, and in this reaction, if heat is a product, because it's exothermic, okay, in order to push it front, you have to remove some heat. You have to remove the heat. You have to remove heat. If you can remove, when I say heat, you have to remove the thermal energy, right? The heat, and then the reaction will drive forward to make more heat, because that's the kind of the stress that you're putting on the system. So I know that was a bit of a long answer, but you can see there's a lot going on here. The first thing you have to realize from the question is what type of stress they're talking about. They tell you increase the equilibrium constant. So straight away you must know it has something to do with temperature. Okay? Is there anybody that did not understand that explanation? Or they want me to go over it again or explain it again in more detail? Anybody? Nobody. Okay. So everyone got it? Okay. Okay, so let's go quickly on to 1.7. After we finish this section, we'll have a small 5-minute break, okay? 1.7. So sulfuric acid ionizes in water according to the following equations. So the equations we have here is H2SO4, sulfuric acid, right? Plus the H2O. And this is going to give us some H3O plus and HSO4 minus. Then that same HSO4 minus here is going into the next step, reacting with another H2O, producing another H3O plus, producing SO4 2 minus. Now the questions are simple. Consider the following statements regarding the ionization above, right? So they're giving you three things. They say H2O acts as a base in both reactions. That's the first one. They're telling you HSO4 minus acts as an ampholyte. And then number 3, SO4 2- is the conjugate base of H2SO4. So which one of the above statements is true? Okay, so don't worry about these answers first. Look at those, figure out what's true, and then come down here and check A, B, C, D. So very quickly, look at the problem, look at the question, and tell me, A, B, C, D, which one is right? You tell me quickly. You just drop it in the chat, right? Okay, I like you to put the answers in the chat because I like to see what you understand and what you don't understand. I don't like to spend too much time on things you understand, right? So if you understand something, please tell me. And if you don't understand something, tell me too, so I can spend time on it. Time is valuable. We don't have much. We only have 2 hours, right? So we have a 1.7. We have a B. Galaxy J6 says B. Anybody else? Everyone says B. Good. The answer is B. Okay, 1 and 2. So H2O is acting as the base. It's accepting the proton in both situations. HSO4 acts as a ampholyte. Okay, so in the first reaction, if you look at the reverse reaction of the first reaction, because that's an equilibrium, right? Wherever you see equilibrium arrow, it means the reaction is actually taking place in both directions. Remember something, an equilibrium is a dynamical equilibrium. We talk about chemical equilibrium, we're talking about a dynamic equilibrium. That means that although you may not think reaction is happening in both directions, it might look like nothing's happening when you're at equilibrium, which means the bulk properties are not changing. On the microscopic level, there's still reaction happening, right? So in this case, HSO4 can react with the H3O plus and go backwards, right? So it can act like a base in that situation. But it can also act like an acid when it reacts with water. HSO4 minus reacts with water and produces H3O plus, so that's correct. And then number 3, the SO4 2- is a conjugate base. That's not. Is that correct? No, that's not correct, right? So answer is 1.7. It's B. It's 1 and 2 in this situation. 1 and 2. Let me just make sure I'm getting everything correct here. 1.7 is B. Number 1. Number 2. Okay. So let's move on. You guys seem to understand that one. 1.8. Which one of the following reaction when used in a voltaic cell will give a positive reading on the voltmeter? Which one of those reactions? Now, I'm not going to ask you for the answer because this requires some work, right? What I'm going to ask you is I want someone to unmute their mic and tell me what they're going to do to find the answer. Anyone, just unmute and tell me how would you approach this problem? If you're sitting in the exam and you're asked this problem, how would you approach it? Anyone? Anyone? Okay, you haven't done this in school yet. No, you must have done this in school. Okay, so this is calculation of electrode potentials. Does everyone know what a voltaic cell is? You haven't done it. I'm sure some of you have done it. So you get two types of electrochemistry cells, right? You get cells that have a spontaneous chemical reaction in them, and that's used to do work. The spontaneous reaction produces the electricity, and you get electrolytic cells where you have a battery on the outside externally driving the reaction. Now this is voltaic cell. What you would do with this question, we have a session later today where we will discuss the electrochemistry, right? But we also have some resources on our website, on our Matric Helpline website, where we have material on electrochemical cells. So when you do that section, you'll be able to come back and make use of this. So what you have to do is you have to go to the back of the paper here. And so you look at your electrode potentials. These are half potentials, right, for each of the half reactions. And then you will calculate. So you've got your magnesium 2 plus magnesium half reaction. You've got your zinc and zinc 2 plus half reaction. You would find the E0 values for them, and you'd combine them. You combine them, right? If you come down here, I did see it. I was going through this. You have this section here, right? So this is showing you how to calculate the E0 value for the cell. So you would, for each of these reactions, you would calculate the E0 value, and then you answer the question, which one would give you a positive reading on the voltmeter. Simple as that, right? And the answer for 1.8 is B. So take that down, B. This question paper will also be uploaded, right? So you can go through it. 1.9, which one of the following statements is correct for the electrolytic cell? Have you guys done electrochemistry just by the show of yes and no? How many of your schools have covered electrochemistry? No one. Okay. So we're probably going to have to do electrochemistry this evening. But the answer here, which one of the following statements is correct for an electrolytic cell? Now, this is a trick question. Let me just explain the trick to you, because a lot of people get confused about this, right? Trick, there's a way to remember this. So you get two of the anode. So you have the cathode, you have the anode. And in school, my teacher taught me red cat, right? And you remember that. You just remember red cat. And so what that means, red cat, is it means that the cathode is where reduction happens. Okay, red cat. Always remember that. So now that I've told you, you'll remember it forever, right? Red cat. Reduction, cathode. Right? Oxidation, anode. And those are, by definition, what happens at those two electrodes. And that's always true, no matter what. Okay? Now, the charge in those electrodes, the potential charge, the relative charge in those electrodes are different, depending on which cell you're dealing with. Galvanic cell, voltaic cell, same thing. Sometimes you're dealing with an electrolytic cell. Now, this may not make sense to you now because you haven't done this, but first thing, oxidation. By definition, that's true. In your, what is it? Let me just check my notes here very quickly. So in your galvanic cell, your cathode would be positive. Okay, it would be positive. And in your electrolytic cell, it would be negative. So there's a lot of misconceptions. Some people will say, oh, the cathode is always positive. No, the cathode is positive in a galvanic cell, and the cathode is negative, okay, in a electrolytic cell. But what the cathode is always the site of reduction, no matter what. And the reason why the polarities change, students, is because the polarity is dependent on where the source of the potential is coming from. If the source of the potential is coming from your cell reaction, that would be your galvanic cell, and that what determines the direction of the potential and makes the cathode positive. When the source of your potential is coming from an external battery, then your cathode is negative, because the battery is determining the polarity across the circuit. So this question has to do with that concept. It's trying to trick you. It's asking you which one of the following statements is correct for an electrolytic cell. So electrolytic cell is the cell that has the battery on the outside. And so they give you all these kinds of, it says anode is positive. So first of all, let me just look at this. Anode is positive. Yeah, it would be positive for a electrolytic cell, right? The cathode is positive. Both can't be true at the same time. The cathode is not positive. It's negative for the electrolytic cell. And oxidation takes place at the cathode? No, that can't be true. We just learned red cat. Red cat says reduction takes place at the cathode. And the number D says reduction takes place at the anode. No, that can't be true, because oxidation takes place at the anode. So B, C, and D is wrong. A is correct. Okay, so it may not make sense to you now, but when you come back and listen to this again, what I said, it's going to make a lot of sense to you, okay? And then very quickly, we're going to do 1.10, and then we're going to take a small 5-minute break, right? Which one of the following shows the industrial processes in which ammonia is a reactant and a product, respectively? So you have a section in your notes for Matric in chemistry that have to do with processes, right? Industrial processes, Oswald reactions, the Haber-Bosch, all of these things. So the answer here is B, right? Which one of the following shows industrial processes in which ammonia is a reactant? That section you must learn. You must learn well. When I was in high school, we had a whole list of processes and reactions, and I would just sit and I would drill them. Every day I would write my reactions out for my different processes until, repetitively write them, buy a writing pad and a pen and just write them, right? But in Matric, I didn't understand everything, but I remembered it, and to get through it. When I came to university and I did chemistry at a high level, I began to understand those things on a deeper level, right? But the point I'm trying to make is that some of these processes, you have to learn them, okay? Completely understand them. So let's take a 10, and then we'll take it from there. We will pick the speed up, right? I'll see you in 5 minutes.
Part of the UKZN experience is the opportunity to be part of a community and to network with not only our world-renowned academics, but with future game changers and leaders. They do say that the extent of one's success can be attributed to those they rub shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply.
All applications for undergraduate studies at UKZN are processed through the Central Application Office, CAO. This is for both your course and student resident application. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom and accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westport. Then, BCN stands for the actual course. Make sure to get these codes right. Step 4. Use the program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. Always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za.
It's that easy. Pay close attention to closing dates for qualifications. For example, MBCHB closes on the 30th of June, whilst other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Ashwin, you're muted.
Okay, sorry, it's 20 past, right? Okay, so welcome back from the break. So we're going to start question 2, right? So this is for 2021 paper, a mid-year paper, Department of Basic Education. So question 2 says the letters A to F in the table below represent 6 organic compounds. So you can see them, they're in the table. A, B, C, and D, E, and F, right? A, B, C, D, E, F. Now, we're going to ask us some questions about these compounds. The first one is, write down the letters that represent the following. 2.1.1, a ketone, right? So which one of these represents a ketone? Quickly in the chat. Keep my chat open, right? Okay, guys, you must have some idea of which is the ketone here, because we did a question. F. Is F the ketone? Yes, F is the ketone, right? We did it in the multiple choice. This is why I'm saying that multiple choice question may have been 2 marks, but the amount of understanding extends to other questions. So if you look at methanoic acid, if you look at pentanal, we dealt with pentanal, right? So pentanal was an aldehyde. Your methanoic acid would be carboxylic acid. Number C, you have C10H22, and you know from your formulas that you deal with, that is CnH2n plus 2, which is your generic kind of alkane. Then D, you can see from D how the connections are made. And remember, in order to have the ketone, you need a carbonyl. So you need this area here, right? You need an oxygen double bonded to a carbon, and then you need some alkyl group here connected to. That would be your ketone. So if you look at all of these compounds, nowhere in these compounds do you have that. It's not here. It's not in E. It's not in D. It's definitely not in C. There's not even oxygen in C. Pentanal we know is an aldehyde. It can't be a ketone. The two are related but not the same thing. And the methanoic acid we know is the carboxylic acid. So it's only F. Okay. 2.1.2, write down the letters that represent the following 2 compounds that are functional isomers. Now the way you do this problem is you have to know what a functional isomer is, right? Now functional isomers are structural isomers that have the same molecular formula, the same number of atoms of the same elements, but the atoms are connected in a different way. So I'm going to say that again. Okay. Functional isomers are a type of structural isomers that have the same molecular formula, that is the same number of atoms of the same elements, but the atoms are connected in different ways. So the first thing to do to figure out which are your functional isomers here is you're looking in this table, you're looking for 2 compounds, right? You're looking for 2 compounds that have the same number of atoms of each type. So you can begin to work a few things out first, right? Methanoic acid. Firstly, what is methanoic acid? How many carbons would methanoic acid have? Now I want you guys to unmute and I want you to tell me, okay? Just put your mic on and just tell me how many carbons would methanoic acid have? Very quickly. would be 1. Okay? It would be 1. So methanoic acid would be 1 carbon. How many carbons does pentanal have? Five. Good. It has 5. We dealt with pentanal. Remember, pentanal was in a multiple choice? So it has the 5 carbons with the carbonyl group and then your hydrogen. So the carbonyl, carbon, and oxygen, and then the hydrogen. It's an aldehyde, right? Put it in the chat. Do you want me to draw these out again? Okay. So methanoic acid is 1 carbon. Pentanal is 5 carbons. How many carbons does C have? You can see that it's got 10. Showing you 10. How many carbons does D have? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And how many carbons does E have? 1, 2, 3, 4, 5, 6. And how many carbons does F have? 1, 2, 3, 4, 5. Now we're in a position, because we know the number of carbons, we can figure out which one of these compounds are possible functional isomers. So you say B and F, right? Someone has said B and F. Okay. They both have 5. Methanoic acid has 1. Nothing else has 1. Can't be methanoic acid, right? Your number C has 10. Nothing else has 10. Can't be C. Your number D has 8. Nothing else has 8. Can't be 8. This is a puzzle, right? Although it's organic chemistry, it's a puzzle. Number E has 6. Nothing else has 6. It's only B and F that both have 5 carbons. And then when you draw them out, right, which I'm going to do now very quickly. Right, so you have this is question 2. So this is question 2, 2.1.2. So your pentanal is 1, 2, 3, 4, 5. And you've got your aldehyde there, and these are, I'm going to do it like this so that you can see the atoms where they connected, right? Because we're trying to show that the connectivity is different, but the number of atoms overall are the same. So this is the number, what is that, B. And then the next one at the bottom is 1, 2, 3, 4, 5. You have oxygen here, nitrogen, nitrogen, nitrogen. Okay, and so when you look at these two, right? When you look at these two, you can see the carbons are 1, 2, 3, 4, 5, right? Hydrogens are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogens are 10. And the oxygen is 1 oxygen present. And in this compound, 1, 2, 3, 4, 5, carbons are 5. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and 1 oxygen. So you can straight away see that the number of atoms for each element is the same in these compounds, but you can clearly see that these are not the same thing. That's not the same. Connectivity is different, okay? And so they are called the functional isomers. So that's the answer. And the way you go about that is some logic and common sense, and you can figure out which ones are the functional isomers. 2.1.3, a hydrocarbon, right? So this compound only contains the hydrogen and the carbon. And of course, the answer must be C, okay? Everything else to some degree has another element in it. There's oxygens in A, there's oxygens in B, there's bromines in D, there's oxygens in E, oxygens in F. Only C has the hydrogen and the carbon. So the answer is C. (2.2) For compound D, write down the homologous series to which it belongs. Okay. So which is compound D? Compound D is the one with the bromines, right? So to which series, homologous series, does it belong? Homologous. You can put it in the chat. Alkyl halides, right? So that's an alkyl halide. And then for compound D, 2.2.2, the IUPAC name. What would the IUPAC name be for this compound? So how would you name compound D? Okay, so whenever you're naming compounds, remember, you need to name after the longest carbon chain, right? So in this setup, you have 1, 2, 3, 4, 5. Now they 6, 7, 8, right? These two CH2s here are connected to each other. So what I'm saying is, after this CH, you have a CH2, CH2, CH3. So there are two CH2s in a row there. See that little subscript 2 outside the bracket? That's showing you that after this carbon, you have a CH2, another CH2, and then a CH3. Okay? Now, there's a reason they drew it like this. They drew it like this because they're trying to trick you. And the reason they're trying to trick you, okay, is that when you name these compounds, and when you're giving numbers to the bromines, you need to give them in such a way that the bromine takes the smallest number and the correct number, right? So somebody says in the chat 3,5 dibromo-octane. That's correct, okay? Because your longest chain is 1, 2, 3, 4, 5, 6, 7, 8. So that's oct, right? And it's octane because they're all single bonds here, right? So it's octane. And your position of the bromines, you gotta label from here 1, 2, 3. This bromine's in position 3. But be careful with this second bromine here, right? 1, 2, 3, 4, 5. That's in the 5th position. So you have 3,5 dibromooctane. Now, some people can make a mistake, and the mistake they can make is they can label from the other direction. So if you label from the other direction, if you label from this side, you get 1, 2, 3, 4, 5, 6. Okay? So you can make a mistake and start from here and get 1, 2, 3, 4, and 6 for the bromines, which is wrong. You need to give those bromines the lowest number possible. So you're starting from this side, which is 1, 2, 3, 4, 5. 3,5 dibromooctane. Very simple, right? Next one. So which one were we? IUPAC name for D. 2.3. Consider the compound F. Right? Write down the IUPAC name of its positional isomer. So look at compound F. Okay. Anybody got any? What is this question asking for? Okay, so someone says pentane 3-O. Now this person is correct. Okay. Let me just, for the rest of you, show you what the question is talking about, right? So you've got this compound for F. This is 2.3.1. You've got 1, 2, 3, 4. 1, 2, 3, 4, and 5. Okay, and you've got your oxygen on that position. And then your hydrogens are everywhere else. Now, it's possible, right, to have this in a different position. It's possible to have this. It's possible to have that in a different position. If you had it in that position, it's effectively the same thing. Okay? Just the other way around, it would be named the same. But if you took this, right, and you put it in that position there, that wouldn't be the same thing. Okay, that would be the isomer we're talking about. And that isomer would be pentane 3-O, because if the carbonyl was here, you'd have 1, 2, 3. It's on the 3rd position, right? And that's the isomer they're talking about. So there are two of them, right? Should I draw it out? I won't draw it out. You guys understand what I'm saying, right? Do I need to draw out the pentane 3O? Okay, I'm not going to draw it out, right? Just shift the carbonyl group to the third position. I'll write down the of its positional isomer 2.3.2, its chain isomer. What's the chain isomer? Okay, so the answer here is 3-methyl butane 2-one. Okay, 3-methyl butane 2-one. Okay, let's move a bit faster now. So 2.4, during the reaction of compound A with compound E, in the presence of an acid catalyst, two products are formed. So during the reaction of compound A with compound E in the presence of an acid catalyst, two products are formed. For the organic product formed, write down the IUPAC name. So let's have a look at what we're dealing with, right? Compound A and compound E. So compound A is methanoic acid, and compound E is an alcohol. So what happens when you take a carboxylic acid and you react it with an alcohol? Anybody? You get an ester. Okay, good. You get an ester. So the question that's being asked, let's scroll to the question. Okay, let me decrease the size of this so we can have it on one. That might be a bit too small for you to see. That might be better. A and E, right? So the question is asking for the organic compound formed. Write down the IUPAC. The IUPAC name 2.4.1. So what's the name of the compound? And they want the structural formula of its functional group. Hexyl methanoate. Okay, so that answers correct, right? Is everyone familiar with this? Do you want me to do it on the whiteboard? The reaction? Just put it in the chat if you want me to. Right, so the IUPAC name is hexyl methanoate, and 2.4.2, the structural formula of its functional group. So its functional group is going to be the ester, okay? So let's do it like this. So you've got, essentially you've got okay, let's not look at that. Okay, so if you've got that, and then you've got your which, right, so that's your A and your E. So the groups of interest that we're looking out for, right, is that group and that group. So whenever you have something like this, you get the reaction that would form the resulting product. So you would have the resulting product here, going with your carbon, hydrogens, carbon, hydrogen, hydrogen. Right, and so that would be where your reaction took place, and the functional group they're asking for is right. That's your 2.4.2. Of course, the other product here is H2O, right? That's essentially what's going on with that question. That's the ester formation, right? Any questions? That would be your hexyl. Methanoate. And that's your functional group that they're talking about. Right, so let's move over to the next question. Right, so the next question is 2.5. And we'll go really quickly through this. Compound C reacts at high temperatures and pressures to form 3-carbon alkene P and alkane Q. Write down the type of reaction that takes place. 2.5.1 is a cracking or elimination reaction, right? 2.5.2, the molecular formula of the compound Q. So the compound Q here, 2.5.2 would be C7H16. And 2.5.3, the structural formula of the compound P, right? So I'll quickly draw the structural formula for the compound P for you. This is 2.5.3. And that's your double bond there, right? So that's 2.5.3. That's the structural formula and the functional group they're asking for in that question. Okay, are there any questions about the question 2? Any questions about question 2? No questions. Okay, what we got 5 minutes left, right? But because we started a bit late, we started 10 past. I'm going to go up to 10 past, right, to give you the full 2 hours. We're going to try question number 3, right? Let's give question number 3 a shot. So 3.5 or 3.1. Define the term of vapor pressure. Okay. So is there anyone here that can unmute and define the vapor pressure? Okay, so the vapor pressure is the pressure exerted by the vapor at equilibrium with its liquid in a closed system. Okay, really simple. Pressure exerted by a vapor at equilibrium with its liquid in a closed system. Okay. 3.2, it says write down the independent variable for this investigation. So what is the independent variable for this investigation? Anybody? So one answer in the chat. Okay, which drawing couldn't you see? Can everyone see this?
Yes, we can.
Okay, I'm talking. Can you see the whiteboard, Lindelma?
Yes, we can.
Okay, so this was the previous question, right? So this is the vapor pressure question. So the question 3.2, write down the independent variable for your investigation. So the independent variable here is the functional group. That's correct, right? Somebody in the chat, Shreya says functional group. So what do they mean by independent variable? So whenever you do an experiment, you do an experiment by measuring something, but you measure something against controlling something else, right? So one of your variables we say is dependent and the other variable is independent. So the independent variable here is the functional groups. We are changing the functional groups in these compounds, and then we're trying to figure out now, right? We're trying to figure out whether or what type of effect that has on the vapor pressure. So question 3.3 says, which compound, A or B, has the higher vapor pressure? So let's look at it. Let's try and think our way through this, right? Which compound, 3.3, has the higher vapor pressure, A or B? You can put it in the chat really quickly. Okay, so someone says B. Okay, now this is where I'm going to ask you guys, right, for one time in the session, you can unmute and tell me why. Anyone? Tell me why B would have the higher vapor pressure. Okay, so 3.4 fully. Okay, 3.4 says fully explain your answer in question 3.3. Include types of intermolecular forces in your explanation. So someone on the chat says because it has the weakest intermolecular force. Okay, so between the two of them, if you're going to have a competition between them now, which one of these guys? Let's think about it. You've got these two liquids. You have two liquids, right? And one of the liquids is A, it's butanol, butane 1-ol, and the other liquid is B, it's butane, it's butane 2-ol. And so these liquids exist as liquid, and there's some vapor that this liquid exists in equilibrium with for both these compounds. So you have the liquid and then you have the vapor. But the compound that produces the higher vapor pressure will have more molecules in the vapor phase. And the reason why it will have more molecules in the vapor phase is because it's easy for those molecules to escape the liquid phase. And the reason why it's easy for it to escape the liquid phase is because the intermolecular forces that are holding it in the liquid phase aren't as strong. So you see, the intermolecular forces in the liquid phase that are holding these compounds in the liquid. Okay, remember, as a gas, they're free to move. In a liquid, the intermolecular forces catch them, the attraction draws them together, holds them in the liquid state. When you use thermal energy, when you put thermal energy into the system, you disrupt those intermolecular bonds and you free the molecules up to become gas or vapor. Gas is a different concept. This is vapor, right? So the question is, fully explain the answer in question 3.3. Now somebody did say because it has the weakest intermolecular force, and that makes sense because if B has weaker intermolecular forces than A, that means more of B's molecules are going to be able to escape the liquid and go into vapor compared to A. I'm going to say that again. If B has weaker intermolecular forces than A, that means more of its molecules will be able to escape the liquid and become vapor, and thus it will have a higher vapor pressure. Okay, that makes sense. Good. The follow-up response is A has strongest intermolecular force because it has hydrogen bonding. Therefore, it has a weak vapor pressure and a higher boiling point. That's the good answer, right? So the compound A, remember when we did the multiple choice and we drew those molecules out and we said that the alcohols have the oxygen connected to the hydrogen, and thus you had a polarized hydrogen that could hydrogen bond with other electronegative atoms in other places. So that's what's going on here. Okay, so A would be able to hydrogen bond and B wouldn't be able to do that. Okay, so that's the explanation for 3.4. Well, the explanation comes in, well, you have to state a few things, right? Compound A, butanol, has hydrogen bonding, dipole and London forces between molecules. Compound butane 2-one has dipole forces and London forces. So both of these compounds have dipole forces, okay, and London forces. But the butane 1-ol has hydrogen bonding, which is a relatively stronger bond than the others. So you've got to state all of those. You've got to state the dipole. You have to state the London forces, and you have to state the hydrogen bonding where relevant. Okay? Don't miss those out. Don't only talk about hydrogen bonding. So 3.5, the graph below represents the relationship between vapor pressure and temperature for compound A at sea level. X and Y represent different temperatures. So you got X and you got Y. Different temperatures, right? It says write down the term for the temperature represented at X. What is the temperature represented at X? Anyone, you can put it in the chat. Anyone? 3.5. It's the boiling point. Okay? See the 101.3 kilopascal? It's an atmosphere. Okay? So write down the term of the temperature represented by X. That's the boiling point. You guys understand that when you have a liquid, and this liquid is in when this liquid is in equilibrium with its vapor pressure, right? The liquid will begin to boil when its vapor pressure equals the atmospheric pressure above it. At that point, when the vapor pressure of the liquid, right, matches the atmospheric pressure, you get the first bubble forming. That's the difference between evaporation and boiling point, right? Evaporation is what happens from the surface. So if you got a cup of water and you place the cup of water on the table, when the water escapes from the surface, that's evaporation. But boiling is different. Boiling is escape of the liquid from inside the solution. Little bubbles form at the boiling point. We call that the point of the first bubble forming. But it has significance, it has meaning. It means that the vapor pressure of the liquid is equivalent to the atmospheric pressure above it. So if you've got a graph like this and you've got 101.3, right, which is special because it's the one atmosphere, and you got a temperature along a vapor pressure curve, then that temperature is the boiling point. The boiling point is the point when the vapor pressure equals the external atmospheric pressure. That's how you know it's the boiling point. Okay? 3.5.1. Now the next one, 3.5.2. State the phase of the compound A at temperature Y and choose from solid, liquid, gas. Now again, please guys, in the chat, solid, liquid, or gas. Anyone? Take a guess. Gas. Anybody else say gas? Anyone for liquid? Anyone for solid? Anyone second the gas? Anyone else thinks it's gas? It's gas, okay? It must be gas because what's happening here is as you, obviously if you're at the boiling point now, this is where your solution begins to boil. If you increase the temperature any further, you're going to drive all of that liquid into gas, right? And number 3.5.3, which is the last question, and this we'll end after this. 3.5.3. Redraw the graph above in your answer book on the same set of axes. Sketch the curve that is obtained for compound C. Clearly label curve A and curve C. So, let's remind ourselves what A and C are first. Right? So butane 1-ol is your A, and C is the propanoic acid. So anyone in the chat, tell me which compound, propanoic acid or the butane 1-ol, is going to have stronger bonds holding it in solution. Which one will have the higher or the lower vapor pressure? Which one, guys? So 3.5.3, they've given you a graph. Oh, terrible. So they've given you a graph like that. And they've got 101.3, and that's vapor pressure in kilopascal. And they've got compound A here. Now they want us to draw a curve for compound C. So compound A was 1, 2, 3, 4. OH. Right? And compound C is let's just quickly look at this. Propanoic acid. So propanoic acid would be 1, 2, 3, and then that. Right. We'll have the hydrogens. And the question is, which one of these two compounds now, if this is A, and that's its curve, what is the curve for B? Now we've got one of two options. It can be this, it can go like that, above A, or it can go like that, below A. Okay? The question is it above or is it below? Because one of these answers is going to get you the marks, and the other one is going to get you a 0. Okay, so we have one person say below. Anybody else second the below? Anyone else second the below? I also think it's below. Okay, so the answer is that it's below, and this is how you would draw it below. The reason why it's below is because at every temperature, if you draw any temperature, right? Let's take this temperature, let's call it T. At that temperature, it's going to have a lower vapor pressure compared to A. And the reason why it has a lower vapor pressure is because less of its molecules escape the liquid. And the reason why less of its molecules escape in the liquid is because there's very stronger forces, types of forces, holding it in the solution. If you look at the different, this is the important area here. But in this compound, when you look at it, you also have the potential for hydrogen bonding here. And there's a potential for hydrogen bonding there. But here you have a very strong dipoles here, right? You've got your carbonyl, which is partially negative, partially positive. So you have a much stronger bonding in this one. And so you will have a lower vapor pressure. And so when you draw the graph, its vapor pressure line needs to be below. So with that question done, we'll call this session a day. I hope this helped you. If your exams are far off and you want to have more sessions, please email us and let us know. And you can bring more of your friends along, and we can assist you the best that we can. Okay, so we've left some links in the chat for the registers. We've left links for the website. We've left the links for email addresses and material, so you can go to the website. It's not just these sessions, right? We had ran sessions last year, end of the year, so all those videos are there. We have really good our lecturers are actually teaching these sections. They're doctors, and they're teaching our access programs. So for life sciences, for maths, and for we have some senior students as well teaching in the maths, and some very senior teachers for the maths. So there's a lot of a wealth of information that you can get from there. And also we have the email boxes. So at any time, if you feel you need help, you can send your email to the email box. You can take a photo on your phone of your question, and you can just forward it to the email box, or you can send an email asking to arrange a session. And we will have weekly sessions moving forward up until the end of the exam. So we want to try and help as many students as possible. So please tell your friends about the program, distribute the website, and good luck for your exams. I hope you do well. And we do have a session this evening, right? So if you can make it for the session as well, you can tell your friends. We will see you in the afternoon. Okay, thank you.
Thank you. Bye, Ashwin. Enjoy the rest of the day.
Okay, cheers. Bye-bye.